little bit further down the Melton Hill Greenway from our previous field trip, and we're at the water's edge. And you can look across the river to the Bull Run steam plant. The smokestack's pretty prominent there. The edges of waters, particularly lakes and streams, are places that are reliably open in the summertime, and we find lots of plants in bloom along there in the summertime. We're going to start out here at the edge of this greenway by looking at a couple of weedy plants, and then we'll walk on down the trail and look at some nice natives. So here's a plant that looks a lot superficially like wild carrot or Queen Anne's lace. Notice clearly an Apiaceae, compound alternate leaves, sheathing bases, these compound umbels. But if we look at the base of the compound umbel, we'll see that there's no bracts there, and that contrasts very strikingly with the wild carrot. These ovaries have bristles like the wild carrot, but the bristles are arranged in a little bit different fashion. This is a weed called hedge parsley. Again, it's in the Apiaceae. The scientific name is Torulus arvensis. Torulus is the genus. Arvensis is a general kind of adjective which means coming from a field. So this is hedge parsley. Growing next to it is our old friend poison ivy, and you can see these pinnately trifoliolate leaves. They're reddish and shiny when they're young, so we'll have to be careful working around this, but we can go in here and see this particular little plant that is a viney, it's kind of actually not a vine, it's an upright thing, but it's sprawling, and you see the alternate compound leaves with stipules. And taking a close look at the flowers, we can see they have the typical papilionaceous kind of arrangement, a banner petal, two wing petals, and a keel, the keel enclosing diadelphous stamens. This is an Fabaceae, and this is a plant that has been planted a lot as a ground cover and escaped. This is crown vetch, and the name for crown vetch is Securigera varia, V-A-R-I-A, Securigera varia. In the older books, it's called Coronilla varia. The genus name has changed. Here's one you'll recognize. It's just starting to peek open. You can see a single ring of perianth parts, which are going to be nice and white. And so this is the calyx, 5 separate sepals, numerous stamens, numerous pistils inside. This is our friend thimbleweed in the Ranunculaceae. That's Anemone virginiana. So we're going to look at a number of shrubs and small trees that grow typically along water's edge. And these are not per se going on your species list unless they have flowers, in which case we'll put them on there. But this is just for your general information as a field botanist. So this plant is sycamore, sometimes called plane tree, Platanus occidentalis. It has these big leaves that look somewhat reminiscent of a maple leaf, but notice the attachment is alternate. And this is a plant that likes to grow in wet areas. If you're thinking of building a house and your intended house site has a big sycamore on it, you may want to take a second look to see where the sinkhole is that the plant is getting its water source from. These will produce their flowers in the springtime in globular inflorescences. We're not seeing on this individual any of those yet. Here's another characteristic wetland kind of small tree, or actually gets to be a pretty good tree. This is green ash. Notice it has these opposite leaves, and the leaves are pinnately compound. Green ash is a plant you need to keep your eyes on if you have a pond, because they can soak out the water from the soil at an amazing rate, and they will actually lead to ponds disappearing and turning into normal kind of terrestrial land by taking the water right out of the pond. These bright yellow-green leaves belong to another characteristic wetland small tree. I'm going to go and harvest this. Looking at some of these leaves might make you a little bit nervous. This one looks to be trifoliolate and pinnately trifoliolate, but if you'll go back to the stem, you'll notice the arrangement of the leaves is opposite. So this is not poison ivy. As this plant matures, it will produce leaves that have typically 5 leaflets on them in a pinnate fashion. This is box elder, and box elder is actually a maple. And so it is in the Sapindaceae, which is the family that has the maples in it. And this is Acer negundo, which is box elder, a characteristic plant we find in wet areas. Here's another characteristic wetland shrub. This one is in bloom, so it's going to go on your list, and we'll take a close look at these flowers. Notice the pretty white flowers. You can see the 4 separate petals, and you can see the 4 stamens coming off of them. And there's a superior ovary associated with this. Actually, it's an inferior ovary, let me correct myself. And this is the genus Cornus. This is Cornus amomum, which goes by the common name of silky cornel. If we look at the stem, you can see the leaves are opposite. And the leaves of dogwoods have this characteristic venation pattern. And if we pull back, we can look and see that one way you can tell a dogwood actually is you tear apart a leaf and the veins remain connected. And so the halves of the leaf will hang together by those sticky kind of extensive veins. So like our more familiar flowering dogwood are the flowers, but they don't have the big bracts associated with the inflorescence of our flowering dogwood that blooms in the spring. This blooms in the early summer, characteristic wetland kind of plant. Cornus amomum, Cornaceae, silky cornel. Here's another characteristic wetland plant. This is black willow, Salix nigra. It's in the Salicaceae. These have unisexual inflorescences in the springtime. We know them as pussy willows. And at this time of year, the fruits are maturing, the seeds have a little tuft of hairs on them, and they're dispersing from this plant. Black willow, Salix nigra, Salicaceae, wetland plant. Striking plant, and you see it lots of places in East Tennessee. You might think it's a native, but actually an introduction from Asia. This is daylily, and daylily is so called because the flowers open for a single day. Here's one that opened yesterday, here's today, here's tomorrow. Let's take a look at the flower here. You can see 6 tepals, 1, 2, 3 outer ones that are a little bit narrower, 1, 2, 3 inner ones that are a little bit fatter, but we would call these tepals. They're all pretty much the same shape and color. 6 stamens, and in the very center of here, surrounded by a hypanthium, I'm going to turn it to the side so you can see the hypanthium here, there is the superior 3-carpellate ovary, and we can go ahead and slit along the edge here and pull this apart. And here down at the base is the green ovary. You see the strikingly green ovary here with the yellow style. And this is a superior ovary. If we cut through it, we'll see it has nice axillary placentation and 3 carpels. So this is a plant. In the old books, it would have been treated in a family called the Liliaceae, but that family with molecular phylogenetic evidence has been dismantled, and now there's a bunch of different segregate families. I'm not sure where your book puts this. We could call it the Hemerocallidaceae. This is Hemerocallis fulva, which is the daylily. Hemerocallis fulva. Now, early on in my field botany teaching career, I would have eaten this plant right in front of class. It is an edible flower, supposedly. A number of years ago, there was a banquet that they had for an edible foods plant class at the University of Michigan. A number of people got sick afterwards, and they traced it back to the daylily. It's uncertain whether it's because the daylily had something poison in it, or perhaps it had been growing next to something that got sprayed on it or splashed on it. In any case, I don't eat these anymore to encourage you to do so. If you want to be adventuresome and try, you're welcome to do so. Just make sure you know the source of the plant. Here's a plant in a family that we've already covered. This has these cute little teeny tiny white flowers on it. Notice the leaves are whorled. And we won't be able to image this in the field, but these little white flowers have 3 or 4 united petals. They have epipetalous stamens and an inferior 2-carpellate ovary. And so this belongs to the family Rubiaceae. And this is another pattern that's common in Rubiaceae, where you have these basically whorled leaves, which are really opposite leaves with stipules becoming developed. The inferior ovary, the actinomorphic corolla, give you a clue that it is Rubiaceae. This is the genus Gallium, and this is Gallium parisiense. And Gallium go by the name of bedstraw, and so it will have some sort of name with bedstraw. We'll have that in a caption for you on the video. This is another characteristic wetland shrub. Most of the year it's pretty inconspicuous. It has these pinnately compound leaves with stipules, and then it has, at this time of year, it has these racemes of little developing legumes. And that gives you a hint that it is in the Fabaceae. This plant is false indigo amorpha fruticosa in the Fabaceae. Characteristic wetland shrub. If you're along the Tennessee Reservoir system, keep your eyes open. It has kind of curious looking purplish flowers in the springtime, followed by these little kind of small legumes. This is just a cute little wetland plant growing sprawling among the other vegetation. Notice the 5 Maris corollas. This is another member of Boraginaceae. It will have a deeply 4-lobed ovary. It will have 4 epipetalous stamens and a deeply 4-lobed ovary with a gynobasic style. Myosotis laxa is the name of the plant, and the genus Myosotis is called forget-me-not. And there are larger flowered forget-me-nots we might grow in a garden and send to our sweetheart so that that person doesn't always remembers us. But this is a nice wetland one, Myosotis laxa forget-me-not, Boraginaceae. Here's another monocot. We're not going to bother keying this one out. It is a family that has 3 nice pronounced petals, and then the stamens are fused to the petals of the leaves. This is Iris germanica. It's an introduced species. And it goes by the name of yellow iris, and most of the time at this time of year you'll see these most prominently in fruit. And another wetland on the plant. Major focus that we're going to be looking at this week are plants that are grasses or look like grasses. And there are 2 families growing along the wet area here that look like grasses, but they're different families. And the first one that we're focusing on here is a juncus. And juncus is characterized by having round stems in cross section, and then they have regular looking flowers, except for the flowers are just very small and brown and scaly. But they have 6 tepals. They have 6 stamens and a 3-carpellate superior ovary. So they're just slightly modified from your normal garden variety plant. The next couple of plants are sedges. And I'll pick a piece of this sedge here that we'll take back and take some good close images of. Sedges have arrangements of flowers in what are called spikelets. Grass spikelets have 2 bracts with each flower. Sedges have only a single bract with each flower. In addition, the sedge stem is triangular in cross-section. The leaves are 3-ranked, and they have a sheath at the base of the leaf that is completely fused around the stem. And there's an amazing diversity of sedges. When you get a practiced eye, you can separate those. And I'm going to back up a little bit along the edge here. You have the delicious possibility that your instructor could go for a swim on this field trip. And we'll reach down here and see if we can pluck some of this other wetland sedge. This is a member of a very large genus called Carex, and the common name for Carex is simply sedge. And in Carex we have 2 different kinds of inflorescences. We have the big fat ones that you can see here very prominently. We'll take a look at these in class with the microscope. These are the pistillate inflorescences. And then at the very terminal part of each plant, you'll have a staminate or male inflorescence. I'm trying to get this to hold still here so you can see it. So that is a bunch of male flowers all clustered together, each flower subtended by a single bract. And this is the genus Carex, has the triangular stem, the closed sheaths, the 3-ranked leaves of the Cyperaceae. By the way, if you want to make money knowing about plants, people that know about wetland plants are in high demand, and particularly if you can tell Carex and Cyperus and Scirpus and Juncus, etc. apart from each other, that's where you can really make a living of knowing about plants. Look at this beautiful yellow flowered plant. This is a small shrub, and it's very characteristic along the banks of Melton Hill Reservoir and other parts of the Tennessee River at this time of year. You'll notice that there are 5 petals. On the undersurface you'll see 5 sepals. What's really striking are the numerous stamens. All of a sudden you're thinking maybe it's a family we know, but then you look at the leaves and they're opposite leaves. And if you look closely at the stamens, you find that the stamens are in bundles or clusters. And then when we look at the pistil in the middle of the flower, we find that there are 3 distinct styles. So it is a compound pistil. So this is not Ranunculaceae or Rosaceae or Magnoliaceae. This in fact is a different family. This is the Hypericaceae. And this is the genus Hypericum. And this is Hypericum densiflorum, which grows along these reservoirs. The common name for Hypericum is St. John's wort. And so we're going to call this one bushy St. John's wort. So bushy St. John's wort in the Hypericaceae. We'll go over the characteristics of this family in a separate part of the lecture. Here's a familiar plant, and you'll get tired of seeing this one if you keep your eyes open as you drive along the roads here. This, of course, is Queen Anne's lace. Notice that compound umbel. Notice that many of these will have a central flower that is purple colored. Nobody knows what the adaptive significance of that is, as far as I know. If we look on the underside of the compound umbel, we find that there's a series of bracts that are closely associated with each of the major branches of that umbel. And that distinguishes it from the hedge parsley we have seen earlier. And then as this goes into fruit, the individual umbels fold up to make this cluster in the center, and the ovaries mature and ripen up, and they get these bristles on them, and those bristles help to disperse the seeds. Wild carrot or Queen Anne's lace, Daucus carota, Apiaceae. Here's a lovely little plant that grows only along wet places along the edges of either lakes or streams or ponds. This is called water willow, but it has nothing to do with the willow family or genus. This is the family Acanthaceae, and the scientific name for this is Justicia americana. So Acanthaceae, Justicia americana, water willow. It has really a distinctive appearance. We may try to dissect the flowers for you, but just the superficial appearance of the plant is pretty much diagnosed. Okay, this kind of robust looking herbaceous perennial plant is a relative of the milkweeds. It's in a related family, Apocynaceae. In fact, some people will put the Asclepiaceae and Apocynaceae in the same family. And they have these small white colored flowers. And the flower parts are very similar to Asclepias, but there's not the fusion of the gynostegium in it. And then you can also see the opposite leaves on the plant. And if we break open a stem, these also have leticifers that will exude some milky sap, as you can see on this leaf petiole. So the common name of this plant is dog hemp, scientifically Apocynon cannabinum, and the family is the Apocynaceae. Grasses are a very widespread family. They're only fourth in number of species, but ecologically they're arguably by far the most important. So it's important to identify those. And this has typical grass features. We'll just look at this superficially. First of all, grasses grow in both wetland and dry terrestrial areas. Here we are at the edge of a forest in a very dry area. We would not expect to find rushes or sedges in this type of area, but we would expect to find lots of grasses. The grass stems are round in cross-section, and they have 2-ranked rather than 3-ranked leaves. So the leaves come off at either side of the stem. Here's leaf A, here's leaf B, either side of the stem, alternating in that. So 2-ranked. If you look down on the top of the stem, there'll be 2 ranks exactly. The leaf has a sheath at its base, and so you can pull away on it, and the sheath is not fused, and the actual node is well below where the leaf appears to diverge from the stem. So you have this basal sheath, this blade that comes off usually at an angle from where it attaches to the sheath. And at that point of attachment, there's usually some sort of a small structure or series of structures that's called the ligule. And these can be important in identifying grass species. The grass inflorescence consists of a series of spikelets, and sometimes these are arranged in a single spike, sometimes as here, they're arranged in an open panicle. And in each spikelet we have a series of bracts. Some of them don't subtend a flower, we say they are sterile. Some of them subtend the flowers, and we say they are fertile. We're going to take a closer look at these in lab, but there are 2 bracts associated with each flower in the grasses. The grasses and the sedges and the rushes are all wind pollinated, and so they don't spend any energy trying to make a showy corolla or calyx, because the wind's going to blow whether they're pretty or not. And so they put their energy into producing lots of pollen, into producing large stigmatic surfaces to catch that pollen.